All right, today we're going to be talking about similar figures. Similar polygons have the same shape but different sizes. The same things go for similar figures in 3D. The angles are congruent and the sides are proportional. The scale factor is the ratio of two corresponding lengths. A ratio is an expression relating two quantities. We typically see it as a fraction or the two numbers with a colon in between them. A proportion is an equation relating two ratios. So let's say 3x over 4 is equal to 2 over 5. That's a proportion. So when we're computing and using ratios for similar figures, we're going to make a chart using E, A, and B. So our first column is always our ratio of corresponding lengths. This is also known as our scale factor. Our second column is our ratio of the areas. This always comes from the scale factor squared. Our third column is going to be our ratio of volumes, and that comes from cubing our scale factor. So whenever we're given information, our volume will always go in the third column, area always in the middle, and if it doesn't say anything that talks about volume or area, it's everything else. So if they're talking about side lengths or radius or circumference, all those things go here. Surface area, lateral area goes here, volume goes here. So if we're given the scale factor and we want to get to the area ratio, we take each thing and we square them. So if the scale factor is 2 over 5, the ratio of the areas would be 4 over 25. If we want to find the ratio of the volumes, we would cube each part of the scale factor. 2 cubed is 8, and 5 cubed is 125. If we're given the area of the ratios, we need to go back to the scale factor first. Well, since we go from scale factor to ratio of areas, we square it. To go backwards, we would do the opposite, which is square root each piece, which would give us 3 over 2. Once we have the scale factor, then we can find the ratio of the volumes. You can't go straight from area to volume. You have to go back to scale factor first. Then we can cube the scale factor, which would give us 27 over 8. Similarly, if we're given the ratio of volumes, we have to go back to scale factor first. Since we cubed to get the volume, we would cube root to go back to scale factor. On your calculator, if you need the cube root button, you push math, and then it's number 4. Now that we have the scale factor, we can square them to get the ratio of areas. This chart is going to help us with almost all the problems we're doing today. So, two similar spheres have circumferences in the ratio 2 to 5. So that's our everything else because it's talking about circumference. That didn't say area or volume in it. Given the volume of the smaller sphere is 4 pi centimeters cubed, what is the volume of the larger sphere? So we're going to start by making our chart. We said that our scale factor or EE ratio is 2 to 5. We just want to know about volume, so we don't even need to worry about the area column. We're going to cube each of these, so 2 cubed is 8, and 5 cubed is 125. Now that we have this ratio, we can set up a proportion. So 8 over 125 has to equal, now it said given the volume of the smaller sphere. We're going to put that on the top because that's where the smaller number from the ratio was. Small with small, big with big. And we want to know the volume of the large sphere. So we're going to put that on the X on the bottom. In order to solve a proportion, remember we cross multiply. So 125 times 48 pi equals 8 times x. 125 times 48 gives me 6,000 pi. And I didn't multiply the pi in yet just because it's easier to write 6,000 instead of the decimal that we're going to get if we multiply it with pi. Equals 8x, divide both sides by 8. Now when I put this in my calculator, I'll type in the pi to get my final, I'm just going to leave it as an exact answer, sorry. So 6,000 divided by 8 is 750 pi. So that's what x equals, and our units are centimeters cubed. Now in this example, we're not given the scale factor. We're going to have to find it. So I'm going to use a highlighter so that I can keep my two different shapes separate. So some information about the volumes and surface area of two similar similar prisms is given. Prism A has a volume of 54 cubic feet. Prism B has a volume of 16 cubic feet, and its surface area is 12. Find the surface area of A. So let's start with my chart. So what information was I given about both prisms? I was given the volume of both. And I'm going to put them in this ratio as A over B, just because A is first in the alphabet. You should get the same answer whether you put A on top or B on top, as long as you're consistent throughout the whole problem. So that would be 54 over 16. Before I move on, I want to simplify this fraction. And if you're not good at simplifying fractions, you can put it in your calculator and then do math, enter, enter to change it to a simplified fraction. So that simplifies to 27 over 8. So now before we can start finding the areas, we need to go to scale factor or EE first. So I'm going to cube root each of these, which gives me 3 over 2. To get my area ratio, I need to square both of those. So I get 9 over 4. That's the ratio I'm going to use because I'm looking for surface area. So 9 over 4 has to equal, remember prism A is on the top, so I'm going to put X over, and then it told me prism B had a surface area of 12. Now I can cross multiply. 9 times 12 equals 4 times X. 9 times 12 is 108 equals 4X. Divide both sides by 4. And I get that X is equal to 27, and our units were feet squared because we're talking about area. That's all for today. I'll see you in class.